Hi everybody, this is Mr. Folly, and welcome to our first lecture on acids. Yay! Don't get any lye in your eye, you won't be able to see the same. Acids are H positive givers in solutions. We're talking about acids and bases. Acids are H positive givers in solution. Remember, an H positive is the exact same thing as a proton, which is the exact same thing as H3O positive. Exactly the same. This is just like your parents and Santa Claus. All right, so H positive is the exact same thing as this, just like your parents and Santa Claus. There's a minor difference, but really no difference. HCl is an acid in water. CH3COOH is an acid in water. NH4 positive is an acid in water. Okay, I'm already confused. What's an acid again? An H positive giver. Okay. HCl is going to give an H positive to water and make H3O positive and leave Cl negative. CH3COOH is an acid. This H right here is the acidic H. It's going to be given to water and make H3O positive and acetate. NH4 positive is an acid in water. NH4 positive gives its H over here. You get H3O positive and NH3. Water is an acid in NH3. Water is going to give its H positive to NH3 and make that. So do you see how acids are H givers? Acids can be identified by their formula. My favorite part is, if it starts with an H, I say that H says, hello, I'm an acid. How did I know this is an acid? Hello, I'm an acid. Hello, I'm an acid. Almost every acid starts with an H, and it says, hello, I'm an acid. It can end in, well, it would end in COOH, but this would be something, COOH. It will end in something, NH3 positive or exactly NH4. Okay, so this is an example of that. It ends in NH3 positive. So that's how you identify them. Biggest, most important one. Hello, I'm an acid. Next one, if it ends in COOH, that's an acid. The other ones, honestly, it's a nice to know thing, but not all that common. Bases are H positive receivers. So we know acids and bases are opposites. If an acid is an H positive giver, a base is an H positive receiver. So NH3 is a base. It's going to receive an H positive. NH3 receiving an H positive becomes NH4. Water is my base in this situation. Water is going to receive an H positive from HCl. If it receives an H positive, it becomes H3O positive. Cl negative is left over. So acids are H positive givers, bases are H positive takers. So there's two types of acids, strong bases and weak bases. Strong bases are group 1 and 2 hydroxides. Okay, strong bases ionize, but we just focus on their OHs. NaOH, as far as we care, is just OH negative. BaOH2, as far as we care, is just 2 OH negatives. So really the other part is a spectator ion. Remember that from a couple weeks ago? Well, maybe more than a couple. But spectator ions means we can just ignore them. It's like they don't happen at all. It's just like if you're Lily. Is she here? I don't know. Didn't even notice. Identification of bases. Bases end in OH. Or they end in something, NH2. Or they end in COO negative. Or just end in a negative. Okay. Water is a base as well as an acid. If you're both, it's called amphiprotic. Amphi means both. Just like an amphibian is both a fish and a critter. So, okay, and I accidentally have some of these labeled. Identifies an acid, base, or neutral. The only neutral we worry about is water. Okay. Hello, I'm an acid. Oh, man. This is a base because it's negative. Negative. This is a negative. It's a base. COOH, that's an acid. Ending in NH2. Oh, I forgot already. Something NH2 is a base. This one ends in NH3 positive. Something NH3 positive, just to show you, was an acid. This one's negative. If it's negative, it's a base. This one ends in OH, it's a base. All right. Bronsted-Lowry conjugate. So we talked about how acids and bases are kind of like enemies. One's giving, one's taking. They need each other. They're blah, 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 blah. Most acid-base reactions are equilibrium reactions, and they are acid-base reactions both ways. So do you see how this is an acid, which means it gives an H to F negative? If it gave one, there you go. If it gave up one of its H's, what's left over? CH3COO negative. So in the forward reaction, this is an acid. It gave an H positive. In the forward reaction, this is a base. It receives an H positive. In the reverse reaction, do you see how this has, hello, I'm an acid, and it's going to give its H over there. If it gave its H, it turns into F negative. Okay. Now, a reverse acid is simply called a conjugate acid. So that's an acid on the left. So if I just flip starting and ending things, an acid gives an H and a base receives an H. But if you're on the right-hand side, you're not called reverse, you're called conjugate. Find the acid base, conjugate acid, conjugate base. So this ain't got no H. If it ain't got no H, it can't give an H. That means it's a base, which means it has to receive a base. COOH, this is the H it's going to give, acid. In the reverse direction, this starts with an H. Does it give up its H when it comes over here? Yep, this is an acid, but it's an acid on the right-hand side. That means it's a spatial acid. It's a conjugate acid. This guy right here receives the H from its friend H3PO4. So it's a base, but it's on the right-hand side, so it's a conjugate base. Okay. Over here, they both start with H's. On the right-hand side, which one of these guys loses its H to go from left to right? Oh. So HCO3 negative gave up its H. That means this is my acid. If this is my acid, the partner will always be the base. Okay. And the reverse, this is the easiest one. This is a base because it ain't got no H. You cannot be an H giver if you don't have an H. So this is my, right-hand side, not just a base, it's a conjugate base. So this has to be my conjugate acid. To find a conjugate acid, treat the substance you are looking at like a base. This means add an H positive. To find the conjugate acid, add an H positive, should say and. Add an H positive. So this becomes NH4 positive. To find the conjugate base, treat the substance you are looking like an acid. To find the conjugate base, remove an H. Take this, remove an H, positive, NO2 negative. Bunch of stuff we wish we still had to know, but we didn't. And that's it. All done. Toodles.